here we have another example for us on the application of Newton's second law. And we have a mass on an incline, 30 degrees, 10 kilogram mass. But now we have a force pushing horizontally against this mass. What will be the acceleration of that block? Again, assuming that mu is equal to 0. And of course, we don't know if this is enough force to push the block up the incline, or if the weight of the block will be enough to make the block accelerate down the incline. So how do we figure that out? Well, let's write down all the forces that we have. We have the weight of the block pulling the block downward, which is mg, which gives us the perpendicular component, which is mg cosine theta. And we have the parallel component to the incline, which is mg sine of theta. Now, since a 100 Newton force, even though it's pushing the block horizontally, it's not horizontally to the incline. So we also have to find the components of this force, which are parallel and perpendicular to the incline. So here we have the parallel component. So this would be F times, and of course this would be the same angle theta, so this would be F times the, that would be the cosine of theta. And then here we have the perpendicular component, so this would be F times the sine of theta. All right. Now notice both the F sine of theta and the mg cosine of theta push the block against the incline, which means we're going to have a normal force pushing back. That's Newton's third law, normal force pushing back, which is going to push back against both this force and this force. So actually we should make it a little bit longer like that. And so the normal force in magnitude is going to be equal to mg cosine theta plus the force times the sine of theta. Of course, that means that this normal component will cancel out this component of the weight and this component of the force. So this is gone, and this is gone. They cancel each other out. Of course, we no longer have this component or this force here because we set out into its two components, and this is now gone as well, which leaves us with just two effective components. We have the mg sine theta trying to push the block down, and we have the force, 100 newtons times the sine of theta, trying to push the block up. Now, I'm going to go on a limb from what I see here, and I believe that this is going to be bigger than this, which means this is going to be aiding in an acceleration up the incline. This is going to be opposing the acceleration, pushing the box down the incline. So I'm going to assume that this is going to be the direction of acceleration, and so I'm going to assume that to be the positive value for the acceleration. So using Newton's second law, F net is equal to mass total times acceleration, or the acceleration is equal to F net divided by mass total. The force that aids acceleration is going to be positive, so it's going to be the force times the sine of theta minus the force that opposes acceleration, which is the mg times the sine of theta. And I think I might have, no, I got a problem here. That's not the sine of theta. The force right here is F cosine theta minus mg sine theta divided by the total mass, which is simply the mass. There's only one. All right, let's plug in the numbers that we have. So we have 100 newtons times the cosine of 30 degrees minus the 10 kilograms times g, 9.8, times the sine of 30 degrees, all divided by the mass of 10 kilograms. So the cosine of 30 is 0.866. So that would be 86.6 newtons minus, that would be 98 divided by 2, which is 49 newtons, divided by 10, and 10 kilograms. And of course, newtons divided by kilograms gives us meters per second squared. So that would be 37.6, that would be 37.6 newtons divided by 10 kilograms, or an acceleration of 3.76 meters per second square. And of course, since it's positive, my initial assumption that the acceleration is upward was correct. This is bigger than this, and so that gives us the answer of 3.76 meters per second squared. Quick calculation to see if I did this right. 36, 37, yep, that looks good. That's the answer. That's how you do a problem like that.